Dig everyone. So in today's class, we'll be looking at sorts. So what are sorts? Sorts are sorts are square roots of numbers that cannot be written as a whole number or as a rational number. So say sorts. Sorts are roots or square roots. Let me just square roots. Square root of numbers that cannot be further simplified as a whole number. Okay. So that is they are irrational numbers. That's the meaning of this part. They are what? They are irrational numbers. And it's number that cannot be written or that cannot be expressed as a fraction. For example, they are irrational numbers. For example, we have this. We have root 3, root 2, root 5. We cannot find the square root of these numbers. If you find the square root, they give you a decimal point. They give you a decimal number. So they don't have a perfect square. They are not perfect squares. So they are like square root of 4, square root of 16, square root of 25, square root of 64, and the likes. So these numbers, they are numbers that you cannot get a perfect number as their roots. So we call them sorts. So if there is this form, root 3, root 2, root 5, root 8, root 7, root 11, and the likes. So sorts, we have roots under sorts, roots or say laws. So number one, square roots of A and B. Square root of A and B. A and B are arbitrary numbers. They are numbers. So it's also the same thing as writing that square root of A times square root of B. So that is just splitting these numbers and giving each of them their own square roots. So square root of with A B, you give you with A times with B. So also the same thing as square root of A times B, which you give what? Square root of AB. So it's still the same thing as this one. So number 2, square root of A, square root of A over B. Is the same as writing is the same thing as root A over root B. So is those same like this one, but the best is that this one is a multiplication, is you are multiplying two numbers, but in this case we are dividing the numbers. So the square root of A over B is the same square root of A over square root of B. So number 3, square root of A over root B. So in this case, we are having the numerator without square without root, while the numerator is having a root. So in this case, right, it's something we call rationalization of sorts. So we are going to rationalize this sort, meaning we are going to multiply the square root of, we are going to multiply this fraction by the denominator, because we have the denominator to be in square root form. So we are going to multiply this fraction by the denominator. So you have to do something like A over with B multiplied by A with B over with B. So you say we are rationalizing this fraction. So when I say rationalize a sort, we are going to multiply the sort by its denominator. So denominator here is root B. For multiplying with B by the fraction, so it will give us A over root B times with B over root B. So we are going to have A times root B over root b times root b. So a times root b give us a root b divided by. So in this case, this brought us to this rule 1 here, where we have root ab is equal to root a times root b. So in this case, to give us square root of b times b. Square root of b times b. So b times b, as we know, you give us b squared. So we're going to have a root b over root b squared. So this is square, this is root. So square can cancel out roots. Why? If you have square root of b squared, this square root, according to law of indices, this square root can be written as the power of 1 over 2. That is b equals power 1 over 2. For this square root here can be represented as 1 over 2. So we are going to we are converting the roots, the square root, to 1 over 2. It means that if we have root a, it's same as having a raised to power 1 over 2. If we have root 2, same as having 2 raised to power 1 over 2. So in this case, this square root here, we'll convert it to what? To 1 over 2. So we still have square. We still have this square here as the power of 2. So we have everything. So we have something like this. So we have b squared into brackets, everything is about what? 1 over 2. So and there's one of the law of doubling that says we can multiply two indexes. That is, if we have a raised power m, the bracket 8 like this, can multiply this m and n together, giving us a power m times 10. That is a raised power ln. So we call it the product rule. That is the product multiplying two indexes together. So in this case, I'm going to multiply 2 times 1 over 2. It will give us b raised power 2 times 1 over 2. 2 into 1 is 2 into 1. Eventually about the b raised power 1. That is b plus of b. So in this case here, so meaning that this square will cancel out the root, which will give us a root b over b. So this is our final answer producer. So this process is called rationalization of sorts. So it means, which means that we are multiplying the fraction by its denominator. So the denominator, we write it in form of a fraction too. The denominator here is what? This would be. So we write it in form of a fraction to give us root b over root b. So root b is the numerator, root b is the denominator. So we are multiplying the fraction by its denominator as a fraction too. So we call the process rationalization. So number 4, fourth root is when we have a plus root b. A plus root b. A plus root b. If we are to conjugate this rule, if we are to conjugate this form of sort, conjugating means that you have to change the sign from plus to minus, or from minus to plus. So in this case, if I to conjugate this word to give us a minus root b. Also, you have a minus root b to also give us a plus root b. So they are vice versa of each other. So they are vice versa. So if you have a plus root b, it give us what? A minus root b. If you have a minus root b, it give us what? A plus root b. So this process is called conjugation of sorts. Conjugation of sorts. You are conjugating the sort. Conjugation of sort. Yes. Why this process here is called rationalization of sorts. Rationalization of sorts. So number 5, if you have let's say you have a over b plus root c. So in this case, you're having the denominator in the same format as the rule number 4 we have here. So we are going to apply two things here. First, we're going to rationalize and we're also going to what? Conjugate. So let's conjugate it first so that we'll be able to rationalize after conjugating it. So we're going to conjugate the denominator only. In this case, the denominator you have is not even a form of the surd. It's just like a normal a simple number. That is a or a simple form. So b plus with c. B plus with c. You conjugate this b plus with c. You will now rationalize it with this fraction. So conjugating with b plus with c. B plus with c. It will be equals to v minus ec. So this is the conjugate of this surd here. So conjugating b plus with c give us what? B minus c. I'm now going to rationalize this surd. So rationalizing this surd, rationalizing, we are going to have a over b plus with c. So multiply by, so in this case, we are now going to multiply this fraction by its conjugate as a fraction also. So it will now become b minus with c over b minus with c. So we're writing what? We're writing our body first. We first conjugated this denominator, then rationalizing it. So we are doing conjugation and rationalization. So multiply this to give us a into bracket b minus with c divided by b plus with c into bracket b minus with c. So let's multiply this out. We are going to use this. We are going to open the bracket. So we multiply this sort by a. So a times b give us ab. A times minus with c will give us minus a with c divided by, when you open the bracket, we're going to multiply these numbers with this all together. So b times b. So we want to multiply b by this surd and multiply root of c by this surd. So we have something like b times b give us b squared. B times b give us b squared. B times minus root c give us minus v root c. So b times minus root c, it give us minus b with c. So that is, you are multiply b by this bracket. So next is to multiply with c by this bracket. So plus with c times b will give us what? Plus b with c. So plus b plus with c times b give us plus b with c. Then with c, okay, we have plus and minus here. So you can first say plus times minus will give us what? Minus. Then would c times would c from this law here to give us c. Would c times would c. Apply this law. It means that we have about c times c. Add this what? Root c square. So the square will cancel out the what? The root. Well, I left it what? C. So here we're going to have c here. So root c times root minus root c gives us c. So we can now simplify it further. So here we have minus b root c plus b root c. So they'll cancel out to that. It's like you have minus 2 plus 2. Simple as saying 2 minus 2. That is 0. So minus b root c plus b root c give us 0. So they cancel each other. Cancel out each other. So you give us 0. So we have a b minus a root c divided by b squared minus c. B squared minus. So this is the final answer we are going to have for this only. So these are the rules of the rules of sort that we have. So we said a sort are square roots of numbers that cannot be further simplified as a whole number, or they are also the rational numbers as a number that cannot be expressed as a fraction, that cannot be expressed as a fraction. For example, root 3 cannot be expressed as a fraction. To give us maybe root of 3 over 1, that's not a fraction, it's just 3. So root 3 will give us 1 point something, 1.7 something. So root 2 will give us 2.4 something, 1.414. So root 5 to give us something in decimal. So meaning that these numbers cannot be, when you apply the square roots, they won't give you a whole number as the final answer, or they will not give you a rational number as the final answer. So they will always be in decimal form. So you cannot find these numbers. You cannot find their square roots, and the square root will give you what? A perfect whole number. So this sort number that cannot give you a perfect number as its final answer. So these are the rules of sorts we have. So we now solve 1 or 2 questions to further simplify and have a good understanding about the topic we are treating. So we have some questions here. Okay. So we have number 1. So you have examples on that sort. So number 1, we have the square root of 75. So how this simplify the square root of 25? How can we simplify it? So 75 is a number that you cannot, that when we find the square root, it will not give us a perfect number. It will not give us a perfect square. It's not a perfect square. It's not like 25, like 4, like 16, like 81, like 64. So they will not give you a perfect square. So this 75 will not be a perfect square. So for what we do is that I want to find two numbers that whenever we multiply them together, they will give us what? They will give us 75. So when we think of it, we can have 25 times 3 give us 75. And it's 25 times 25 plus 75 plus 25. In this case, you have to give us 75. So in this case, we're going to have square root of 25 multiplied by 3. So we cannot apply our first rule here. The first rule we have, so that is, if we have square root of a and b, so a times b, you can separate these numbers and give each of them their roots. So we're going to have it as square root of 25 times square root of 3. So what's square root of 25? That is 5. That is 5 times root 3. 5 times root 3. So which will give us what? To give us 5 root 3. So this is how we can simplify 75 in a simple form. So next question is square root of 18. Square root of 18. So 18 is not a perfect number. Does not have a perfect square root. Yes, it does not have a perfect square root. So we will put the parent number out. Don't multiply them together to give us 18. So which is 9 times 2 or 6 times 3, 18. So if we use 6 times 3, 6 times 3, 6 is not a perfect number. 3 is not a perfect number. So we're going to find two numbers that one of them is a perfect number, while the second one is not a perfect number. So 9 times 2 is pretty because 9 is the perfect number, while 2 is not a perfect number. So 9 so it's better for us to use 9 times 2 than using 6 times 3, because both of these numbers here, they are not a perfect number. But in this case, we have one of them as a perfect number. So we are going to use 9 times 2. So we are going to have square root of 9 times 2. So to give us root 9 times root 2. Root 9 was as is 3. But 3 times root 2 to give us what? 3 root 2. So number 3. We have square root of 72 over square root of 72 over 80. So this question too, you can apply one of the rules, one of the rules, I think is root 3. The root 3, you can apply the root 3 to this question. So we are going to separate, give each of them their square roots. So they become root of 72 divided by root 3. So how can we simplify root square root of 72? So you can do it as 12 times 6, that is 12 times 6. 12 times 6 will give us 72. 24 times 3 will give us 72. So you can use either of these rows to simplify 72. 14. Okay. So I'm going to have root 12 times 6 divided by root 3. So you can use either this or this. You can use one of them. So we're going to have root 12 times root 6 divided by root 3. So for this one, consider that there's nothing that's common here. Although we can further simplify 12 as root 6 times root 2. Why can write this one as root 3 times root 2? So we're going to have root 6 times root 2. That is for 12. Then root 3 times root 2 divided by root 3. So we can cancel out. We can cancel out root 3. Root 3 cancel out root 3. So I'm left with root 6 times root 2 times root 2. So root 2 times root 2 will give us what? Will give us 2. From this place, you are able to explain how we got root c times c. So root 2 times root 2 will give us 2. Because root 2 times root 2. That is, it give us square root of 2 times 2. That is what? Square root of 4, which is equal to 2. So in that case, I'm going to have root 6 times 2 to give us what? 2 root 6. Final answer. So we are going to stop here for today's class. So that we are going to take it bit by bit. So after all, we are going to look into other questions on logarithm, or even on sorts that we are going to take by questions too in other sorts. So we are going to look into the topics further. So let's stop here for today. So let's subscribe and comment and like the video. So if you have any other topics you want us to discuss or explain, so let's write them in the comment section. So thank you all for staying for the class.